So the electrical or electric power. So what is electric power? Electric power is the rate at which the energy is used up. The rate at which what the electrical energy in the circuit is being transferred to another form is what we call what? Electric what? Power. And the power is measured in what? In watts. So by definition, I say what? The power, this is the rate, or this is the time rate at which at which the energy is used up. And power is measured in watts. The unit of power is what? Is watts. So mathematically, of doing work, or is the time rate at which energy use up, electric energy is being what is used up in a circuit. That is what power. Mathematically, we can have power to be equal to the what? Work done or energy used up over what? Over time. So if you are using this, we can say that what? Where what? W, which is work, electric energy, is equal to the what? IV T. If the work or the electric energy in a circuit is IVT, we can have what? Electric power should be equal to what? IVT over what? T. So this T will cancel each other. Therefore, electric power will be equal to the what? IV. This is what? The equation 1 for power. And furthermore, you can say that from Ohm's law, what is V? V equal to the what? I R. If we have V equal to the I have, substitute over V here. We have power to be equal to what? I. V is what? I have. We now have what? Electric power will be I square R, which is what? Equation 2. So from this same Ohm's law, let us make R really the formula. You can also say where R is equal to what? From this expression, potential difference over what? Over current I. By substituting for what? For this R here, we are going to have power to be I square into V over what? Mm-mm. No, excuse me, excuse me. Mm, no, this is what I need here. Let me make I sort of formula here. By making I sort of formula here, we have I should be equal to the what? V over what? What am I going to have next? Electric power should be what? P. What is I? I now here is what? V R everything squared dot what? This R. So by expanding it, you will have what? Power should be what? This R will cancel one R here. We are left with what? V square over what? R square. This is what? The third equation of what? The third equation of what? Of power. So whenever you are asked to find the electric what? Electric power. So in terms of what? Of current and the potential difference, apply this one. In terms of what? Of current and resistor, apply this one. In terms of voltage and this, apply what? This. So example one, let me say you're asked to calculate the power dissipated, power dissipated by a heater of 220 volts and resistance of 10 ohms. We are asked to find the what? The power, there's what? Dissipated by heater of 220 volts and resistance of 10 watts, 10 ohms. So here, solution. The solution here, what are the parameters given? We are given potential difference of 220 volts and the resistors of what? Resistor of 10 watts ohms. Which of the resistance? This formula comprises of resistors and potential difference. Look at the equation one. It's comprised of what? Current I and potential difference. Equation two, I and resistor current. Equation three, potential difference and how. Automatically, we are going to use what? The equation what? Equation three. Can I say using Equation 3. Power equal to what? V squared over what? Over R. By using this expression, we are going to have what? The power to be equal. What is V? 220 volts squared. Resistor is what? Is 10 watts. 10 ohms. So by pressing this now, we are going to have what? Power will be equal. This 20 is 400 divided by 10. Cancel each other. Therefore, the power dissipated is 484 these watts. So then example what? Example 2. So let's solve these two. This example 2. We are given a 70 watt electric iron is connected to a 220 volts main supply. Calculate the current drawing the iron or by the iron, and B, resistance of its heating element. C, the heat generating in 1 minute. So solution. Solution. So for this, we are given power. So P is what? 750 watts. Main supply. 750 watts electric iron is connected to a 220 volts. Potential difference is 220 volts. Good. We are now asked to calculate the current drawn by the iron. So A, the current drawn by the iron, but to calculate the what? The current what? I. Which formula relate power, potential difference, and current together? Equation 1. Right? So we can now say what? Using P equal to the what? IV. We are looking for the current. So the I will be what? Power over what? Over V. What is the power given? Power given is 750 watts over 220. So let's divide 220. Let me divide 2 watts. 750 divided by what? This 220. If you have known is 3.41. So therefore the current I is equal to what? 3.41 ampere. That is the current. The next one is B. We have to find the resistance. To calculate the what? Resistance. Which formula relate power, current, and resistance together? Or we can use what? Which formula relate resistance, potential difference, and the power together? This. So we can use it in this form, that using equation 3, or we can use Ohm's law. We know the potential difference, we know this one. If we use Ohm's law, V equal to the what? I have. But let's use power. You can use this word. You can also use what Ohm's law, which saying that what V equal to what I R. So which one can we use? Hmm. Let us use this formula. Power equal to the what V square over what R. So we can have what our R equal to what V square over what power. What is the V square? 220 everything square divided by what? 750. So if you square what? Yeah, it's like I used 220 years before, yes. If you square 220, we have what? 48400 divided by what? 750. Divided by 750, 48400 divided by what? 750. We have 64.5. So the resistor is what? 64.5 ohms. If we apply this Ohm's law by using what? The resistance is equal to the what? IV over R. We must get the same thing, which is what? 220. What is current? 3.41. If you press it, you must get this. The same thing. So this is the answer for resistance. The last one is C. To what? To calculate heat generated. Generated. To know the heat generated, you can use what? Using power because of the what? Heat generated over what? Time. So from this expression, we can have it in this form that heat generated is equal to what? Power times what? Time. So the heat generated, what is power? 750 watts. What is time? In 1 minute. 1 minute means what? 60 seconds. 60 what? Seconds. 750 times 60 seconds is the amount of what? Of heat generated. So to give us what? 45,000 joule. 45,000 joule. Therefore, the heat generated is 4 kilojoule. So I think we are okay with what these two examples of what of electric power. So let us now move to what we call what the types of electric what electric power. So let us look at what the types of electric power. The electric power are of three types. Types of what electric power of electric power. So they are of three what of three types. The first one we have real power. Real what? Real power. We can also call it what? Active power. And is always denoted by P. Active power, we can also call it what? Real power. And the next one we have apparent power. apparent. The apparent power is known as what? X. The third one, we have reactive power. Reactive power is known as what? Q. So these are the what? The three types of electric power we have. So let's take it one after the what? Other. What's the next one? Real power. Real what? Power. I use P to denote what? To denote it. As the name implies, is the actual power consumed in a circuit. The actual power consumed in a what? In a circuit to do a useful work is called real power. So real power is what? Is the actual power consumed or used in a circuit to do useful work. The actual power consumed by a circuit to do a useful work, we call it what? Real power. Or I can also say, or the power used in driving machine. So let's call it what? Power used in what? In driving machine. Driving what? Machine. In the factory in which power factor, in which power what? This is the power factor. The power factor, we call it what? Cos theta. I will explain it later. In which the power what factor is considered. E.g., example of real power. Running motor, yes. Running what? Motor. Lightning bulb. So the power consumed by this electric bulb, we call it what? Real power. Real power is the actual power consumed by a circuit. Or if electric motor is what is driving, the power consumed by driving the what? The rotor of the motor is called real power. And the real power always consider the power factor. What is power factor? Cos theta. The power factor here simply means what? Cos what? Cos theta. Can I say what? The formula for power, real power, sorry. So my real power, yes, formula for real power. So the real what? Real power for every machine or circuit, it will be what? I V cos what? Cos theta. Call it what? Equation 1. So whenever you have what? Asked to calculate the real power is what? IV cos what? Cos theta. That is the formula for what? The real power. And the next power is apparent power. Apparent. So the apparent power is total power supply to a circuit apparent power. So the apparent power, I'm using what? X. The symbol for apparent power is X. So this is a what? A total power supply to a circuit, whether used or not used. The apparent power, this is the what? The total power supply supplied to supplied to a circuit, whether used or not. See, the power that supply to electric circuits, the power that supply to what? Electric circuits, the total power supplied to a circuit is called apparent power. But the actual power consumed or used by the circuit, we call it real power. All the power supply to the circuit from the source are called apparent. But the useful one is called real power, IV cos theta. So, what is the formula for this now? So, I can say from power factor, which is equal to what? Real power over apparent. Current what? Power. So, from this expression, let's make apparent into the formula. So I can have apparent power should be apparent power equal to what? Real power over what? Power factor. From the definition of real power, I mentioned power factor here. Power factor simply stands for cos what? Cos theta. So from stands for what? Cos what? Cos theta. So you can say what? Where power factor is cos what? Cos theta. So let us put it here. You will now have what? The apparent power to be equal. What real what? Real power. What is the real power? Real power is IV cos theta. We have it here. Over power factor, which is what? Cos theta. Cancel. You will now have what? IV. So therefore, apparent power equal to what? IV. Let me call it what? Equation 2. The power, the total power that's supplied to electric circuit is called apparent. The actual power that is useful or consumed by the what? By the circuit is called real power. The power consumed by this electric what? Bulb is called real power. So the power consumed by the socket to supply the TV set, we call it what? Real power. But if I now sum the what? The power of electric bulb, the one that supply the fan, And the TV set, we call it what? Power. So the next one is reactive power. Reactive what? Power. Reactive power. But the reactive power I'm using Q to what? The symbol for reactive power is what? Is Q. What is the reactive power? Is the power that oscillates between the source and the reactive component in the circuit. The what? Power that oscillates, oscillation, oscillates between the source and the reactive component. Between the what? Source and reactive components. What are the reactive components? So you know we have done active components and the passive components. Reactive what? Components like, let me open brackets, component like inductor, yes, and capacitor. Good. The power that oscillates between the source of the power and the reactive component is called reactive power what? Power Q. Let me add this to it. The reactive, it does not, it does, this does not do useful work, but is essential. Is what? Essential for maintenance or is essential for maintaining the electric the electric field and magnetic field. This power does not do any useful work, but it's very essential to maintaining the what? Electric field and what? Magnetic what? Magnetic field. So we can say that is what? The reactive power can say that the reactive power is also equal to what? Mathematically, the reactive power is equal to what? IV. So this is the formula for reactive what? Power. Call it what? Equation what? Equation 3. But to understand the three, there is a parameters of physical quantity that combine the real, apparent, and the reactive power to what? Together. Yes, no, there is a quantity that is combined what? what am I call it? Reactive power and apparent power together. So what is the name of the quantity? Let us move to the what we call power triangle. Power triangle. What is power triangle? Power triangle, excuse me, power triangle is a graphical illustration that show the relationship between the three types of power we have here: real, apparent, and refractive index. So this power triangle is a triangle that show the relationship between the what? The real power, apparent power, and the reactive what? Power. So the power triangle, this is the what? Is a graphical representation that illustrates the relationship between real power. Real power is known as P. Apparent power, apparent what? Power. The apparent power, apparent, is known as X, and reactive what? Power, which is known as what? Q. Let me show the triangle. So this is the triangle. Here we have angle 90. This side is face angle. So the opposite side of the triangle, we call it what? Reactive power. Reactive power, which is what? Q. The opposite of triangle. The longest side of triangle, we call it apparent power. Apparent power, which is known as what? X. The adjacent, the horizontal component of the triangle, we call it what? Real power. So the power triangle show the relationship between the real, reactive, and apparent what? Power. So, excuse me, from the knowledge of mathematics, there are three theories that show the relationship in a right angle triangle. The first one, we have Pythagoras theorem for the side. The second one, we have Choctaw for the angle. So I cannot say by Pythagoras, Pythagoras theorem. What is Pythagoras theorem? We have this side is called opposite. This place is hypotenuse. This is adjacent. So Pythagoras said that what opposite square plus adjacent square equal to the hypotenuse square. What is opposite square? The opposite square here is what? Is Q. Adjacent is real power, which is P. Hypotenuse is X. So if you are looking for the X, which is what? Apparent power. Or if you are looking for the what? Let me say you are looking for the Q. Reactive what? Power. The Q will be what? Q square S square minus P square. Q will be square root of what? S square minus P square. This is what? The formula for reactive what? Power. Let me call it equation 4. The last one is by using Shokatua. By Shokatua. If we take cos, our interest is cos. If we take cos theta here, theta, sorry, cos first angle will be equal to what? K, adjacent. Real power, K, hypotenuse, is apparent power. Apparent power. By substitute for the each value, cos of this first angle, what is real power? The real power formula is IV cos theta. Put it here. We have IV cos theta and apparent power is what? IV. IV. So the IV cancel IV. We are left with what? Cos what? Cos theta. You know, if you look at what? This car we check here is the same thing as what? Power what? Factor. Call it what? Power what? Factor. Therefore, you can now say what? The power factor is real. You know, I said it here before. Real power over what? Apparent power. I said it before now. So you can now have what? Power factor. It should now be what? Cause this. You can now say what? Therefore, power factor is equal to what? Cos what? Cos angle of this triangle. That is the formula for power what? Factor. So let's solve 2 or more questions on this. So let's solve these questions. Solution. A circuit has a voltage of 230. V is what? 230 volts. And a current I is 10 ampere. If the power factor is, we are given power what? Factor, which is what? Cos theta, or is 0. What? 8. You are now asked to calculate the real power. From figure 1, calculate the real what? Real power, calculate the real power, calculate apparent power, and watts. The real power, apparent power, and reactive watts power. From this question, if you want to calculate the real power, come to this side. We know that is what? The formula for real power, real watts power, we have done it before, is equal to the what? IV cos what? Theta. IV power factor. Abi? But the apparent power, we know is IV. So we can use what? The apparent power, apparent what? Power and the real power to find the what? To find the reactive power. So here now, in this question, we can first of all find the what? The apparent power. It's very easy for us to what? To find. And say what? To calculate apparent power. P. What is symbol for apparent power? Is X. So using this formula, using formula for apparent power, so the apparent power is IV. So we can now upgrade to what? To the apparent power, which is what? IV. So what? Apparent power. What is I? I given is what? Is 10. What is potential difference? 230. Therefore, apparent power will be equal to 2300 watts. That is apparent power. So the next thing that we can do now is what? Roman figure 2. To calculate the real power. What is the formula for real power? Using, real power will be equal to what? IV cos theta. And this cos theta is power factor. You can also say that what? Where what? Power what? Factor is cos theta 0.18. Therefore, this will now be what? Real power will be equal. What is IV given? We get what? IV is 10 multiplied by 230. Cos theta is what? 0.8. The power factor we have there. So by pressing the calculator So, what are we going to have here? We have real power should be 2 this 0 multiplied by 0. What? 8. Let me multiply it. Where is my calculator? By multiply it here. 2300 multiplied by 0.8. 1840 to give us what? Real power is 1840. Real power, everything in what? In watts. So that is what we get for real power. Hope I'm right. Yes, that is the real what? Power. The next one is we are asked to find the what? We are asked to find the reactive power. So we can say equation Roman figure 3 to calculate the reactive power. So the reactive power can be what? By using the equation 4 that we have what? Reactive power is what? Is Q. So the reactive, let me write it out using this that we are what? Reactive power Q is square root of x square minus p square. You remember it? Let us apply the formula. We have Q should be square root of this. What is my x? X is 2300 everything square minus this is what? 18400 everything square. And this, if I press the calculator further, we have what? Square this. It will give you what? 529000 minus square this 18 for the square. We have what? Minus 3385600. So if you have this, subtract, your Q should be give you what? 194,400. 440 what? 0. By pressing the calculator, we have 138 watts. That is what the reactive power from the question above. Let me add one more question. So let's solve this second question here. Solution. A load has a real power of 500 watts. Real power of 5,000 watts, and a power factor of 0.9. If the voltage voltage. V is what? 400 volts. Calculate the apparent power. Power is unknown, and calculate current. I is also what? Unknown. So to know the what? The apparent power, I can say from my figure 1 to calculate the apparent power. Good. I will say using power factor equal to what? Real power over apparent power. Power. From this expression, the apparent power can now be what? Real power over what? Real what? Real power over power factor. What will be the apparent now? Apparent power. What is real power given? 500,000 watts over power factor is 0.9. If you press your calculator, you are going to end up with apparent will be equal to power. Will give us what? 5555.56 watts. And the next one is 2. You have to find the current. Say what? To calculate the current I using our real power, using using apparent power, E equal to what? IV, apparent power. So our P here is what? Is what we get here. The current I, it will now be what? Apparent power over potential difference, V. So current I will be what? 5555.56. Everything over what? Potential difference is 400. If you press the calculator for the current, we have 113.89 ampere. That is the value for what? For current. So I will give you the third questions on this, and then you will help me to what? To solve it. And tell me the answer in the comment section. Look at these questions now. Here you are given a circuit has an apparent power of this apparent power, and a reactive power of 60 watts. Then calculate the real and the power factor. So to solve this question, it's very simple. To know the real, what we use to know the what? The real power. If we apply the power triangle, we say that is what? The active power, we say that what? Active power square is equal to the what? The real power square plus reactive power square. Apply this from this formula now. We are looking for the what? We are asked to find the real power. Good. So this is what? Is reactive power. This is the real power. This one is what? Is apparent power. So the real power now be what? Square root of apparent power minus what? Reactive power. Use this formula to get this. From this question now, our apparent power is 1000. The Q is what? Is this. You now have what? The P equal to the what? 1000 square minus 600 square. So if you square it, the final answer you get here, it will serve as your what? As your real. It serves as your what? As a real power. You are now asked to find the apparent power. Do you forget that is what? Real power, you will use now for what? That real power. So the what? IV power what? Power factor, which is cos theta. Abi? So, or you cannot use this. Do you remember that I told you that is what? The power factor, where is it here? Power factor is equal to the what? Real power over what? Upper what? Apparent power. So the real power you get here over what? Apparent. You get the power what? Power factor. Please solve it and tell me your answer in the comment section. So we are done with what? Electric energy and power. So our next topic is magnetism.